This is the Maths Numeracy Unit 1 Non-Calculator Higher Tier Answers. This is the November 2017. So this is non-calculator, so don't forget you can't use a calculator, obviously. So question 1. Okay, I apologise for my pronunciation. Ysgol Fron Isla, I'm not going to say that again, and Ysgol Cywen are two very different high schools. The one is a larger school in a rural area. The other is a small school in a town. The town in which the small school is situated has many traffic-free cycle routes. All of the pupils in year 7 to 8 were surveyed with both of the following questions. So, do you cycle to school? If you answered no, would you like to cycle to school? Results were displayed in the graphs below. So the black is cycle, the grey is would like to cycle, and white was other. Which school in your group has approximately equal splits between 3 categories? So you want them all equal. So it's clearly this one. Why is my pen not working? So it's clearly this one. So it's Ysgol Cywen and year 10. So Ysgol, why is that writing weird? Ysgol Cywen, that's me, and year group 10. Circle the true or false for each of the following statements. There are definitely more pupils in Ysgol Fron than cycle to school than in Ysgol Cywen. Nowhere has it told you that the amount of pupils. You could have the rural school be really, really small. So even though like this is 40%, that could be 40% of a very, very small number. Whereas this year 10 class would be about 37%, 36% of, oh no, that's about 32. About 32% of like a very, very big number, which probably be more. So you haven't been told how many pupils are there, so you can't say which one has more pupils and which one doesn't. Both schools have pupils in each year group with no interest in cycling. So both have white in all of them. Well, yeah, they both have white in. The questions asked were biased. They're not leading, so they're not making them answer a particular question. So do you cycle to school? Yes or no, that's fine. If they said, you cycle to school, don't you? That's a leading question. So that wants you to answer yes. So that would be biased. So that's not biased, they're fine. Approximately 20% of the people surveyed in Ysgol Cywen cycle to school. So this is the second one. So year 7, 20%, year 8, 20%, year 9 just below, and year 10 just above. So if I took that and put it there, it'd probably be about 20%. So yeah, they averagely are about 20%. It's more likely that in Ysgol Fron there is a small school situated in a town. Well, they said earlier that they have cycle routes in that place, so you would expect them more people to cycle. So because all the black bits are bigger, I'd say yeah, it's more likely. It's not certain, but because they haven't said it's definitely, isn't it? You wouldn't be able to tell, but it is more likely. I'd say yeah. In January 2011, there was 1,200 miles of national cycle network routes in Wales. In January 2016, there was 1,400 routes in Wales. The number of miles and routes will continue to increase by the same number of miles per year. How many miles would there be in 2018? So in 2011, there was 1,200. In 2016, so 5 years later, there was 1,400. So that's an increase of 200 miles. But that's split between 5 years. So each year, there was added 40 miles added each year. So in 2017, there would be 1,440. So in 2018, there'd be 1,480. So it'd be a very common mistake to add two lots of 200 to that question, because you might not have been seeing the one 2011 and 2016. But don't forget you have to split that between the 5 years. Why is your answer in part 1 unlikely to be an accurate estimate of the number of miles of routes in 2018? Well, just because they increased in the previous years at a constant rate doesn't mean in the next year they will increase by a constant rate. So it would be unlikely that the constant rate of increase each year. So it's unlikely that they'll continue going up by 40. They could, but they might not. Next question. William, I can pronounce that, owns and runs dog kennels. His cost depends on the number of dogs in the kennels. The run cost for 1 day is shown in the graph below. Why doesn't the graph go through 0, 0? Obviously, if you had no dogs, it would cost you nothing. Obviously, you're not putting your dog in there. But it has a fixed cost, so no matter how many dogs you put in, there's always that fixed cost added. That's the same with lots of things. You pay per amount, but there's a fixed rate that you've got to pay plus any additional dogs. So you just put fixed cost. What is the increase in the daily running cost for each additional dog that's kept in the kennels? So we basically, you could find like the gradient if you wanted to, but I'm just going to use my common sense. So when there are 10 dogs, there's 50. When there's, it costs £50. When there's 20 dogs, that is on £90. When there's 30, that is on 110, 20, 30. So when there are 10 dogs, I'll just write this. When there are 10 dogs, that was £50. When there was 20 dogs, that was 90, wasn't it? Yeah, £90. When there was 30 dogs, there was 130. So each time they add in 40, so an extra, to add 10 dogs, they would add 40. So to add one dog, it would be an add of £4. So there's an increase of £4 per dog. So if you add an extra dog, it's an extra £4. Frida also runs a dog kennel. The cost of keeping 20 dogs in her kennel in one day is £130. She knows that this is the number of dogs increases. She knows that as the number of dogs increases, the overall cost increases at the same rate as William's. So basically, they're parallel to each other. Displays information on the graph, paper opposite. So at 20, hers was 130, which is here. You want a straight line. Put your ruler against this line, and then just move it up until your dot. Mine is not going to be accurate because I can't put a, ooh, that's pretty good. That's pretty decent. I'm pretty happy with that. So they're parallel, and it goes through that 130 at 20. Find the cost of keeping 30 dogs for one day in Kendra's kennel. So I'm going to go up to 30. I'm going to read across. That's about 150, 60. It's about there, isn't it? So yeah, so about 170. I think you can put just below 170, like if you put 169 or 168, that's probably fine. Your line is just a bit different to mine. But you could have also, I mean, if it's 130 and hers goes up by every £4 as well. Right, next one. Question 3. Miriam's window cleaning business. No job too small. Go Miriam. Miriam's window cleaner, as stated. From Monday to Friday, she records how long he spends. Oh, it's a man. Miriam is a man's name, okay. For each of his customers, he draws a cumulative frequency diagram to display the findings. Use Miriam's cumulative frequency diagram to find the median and interquartile range of the time he spent. I honestly thought that was a woman's name. So it goes up to 120. So to find the median, you'd go to 60. Half of 120 is 60, and we read down. Ooh, I had my ruler in already, and I didn't really know. So it's 15, 16, on 17 exactly. So it's on 17 minutes, so each one was 2. So 15, 16, 17. To do the interquartile range, so the median is half. The interquartile range, you're going to need your lower quartile, which is half of your median, or a quarter of your total. And your upper quartile is 3/4. And then interquartile range is the difference between those two. So your lower quartile would be 14, and your upper quartile 18 maybe. Yeah, so I've got my upper quartile as not 18, that's 19 one away, isn't it? Yeah, 19, and my lower quartile was, I want to say 14, I can't remember. Yep, 14. Take those away, 19 take away 14, I get my interquartile range, which is 5. She looks back at her raw data and finds the median is actually 17 minutes and 30 seconds. Why is there a difference between the median and cumulative frequency diagram and the actual median is raw data? Cumulative frequency is about group data, and it's an estimate. So anything along those lines. As long as you include those two words somewhere in your sentence, that's fine. Group data is always an estimate, because you don't know, like that category there that we found our median in. You could have had all the people here, you could have had all the people here. They could have been anywhere. That's horrible. But it's an estimate. Miriam is looking at the time it took to clean individual customers' windows. Find the number of customers whose windows took between 10 and 15 minutes to clean. So we're going from, I know you can't do this, but I'm going to rip out my lines. So from 10 to 15 minutes, so you want to go up from 15, read across, up from 20, read across, and take them away. So when I went up from 20, I get, it is from 15 to 20, no. No, it's from 10 to 15. Sorry. So you want to go up from 10, up from 15, and read across. So if I go across from 10, we get about 12, yeah. And up from 15, that's about 34. Each one is 2, so 34, take away 12, and you get people between them. 34, take away 12, 22 people. Mary thinks that approximately 80% of his customers, he cleaned their windows in less than 20 minutes. So 80% of his customers, he had 120. So 80% of 120 is 96. So you could have 10%, 12, times it by 8, which is 96. Let's find out how many are less than 20 minutes. So go up to 20, go from 20 and read across. It's about 102, isn't it? So yeah, definitely there's more than that. So less than 20 is 102. So yes, he had more than 80%. Then got that. Okay, Megan Pugh's, I can say that name also. Electricity bill, can't even say the word bill, is shown below. It covers the period of May, June, July. It's 2017. So we've got her previous meter readings, her present, so they've worked out how much electricity she's used. It's charged at 20p, so they've times by 20p. They add standing charge, that fixed cost I mentioned earlier, 3 times 760 to get a total charge. Then they add 5%, and they get the total amount to pay is 118, but we're going to have to do something similar to that. On the 1st of August, the charge per electricity was increased by 5%. So charge per electricity was 20p, so we want 5% of 20 pence. Well, 10% is 2 pence, so 5%, half of that is 1 pence, so 20 pence at 1 pence is 21 pence. In this part of the question, you'll be assessing the quality of your organisation, so it's an OCW question. You should know what that stands for by now. Megan wants to calculate her next 3 months' electricity bill. She knows the following. Her meter reading on the 31st of October was 14,400. Charge per electricity is increased by 5%, so it's now 21p like we calculated earlier. Standing charge is increased by 20 pence per month, and VAT remains at 5%. Then she's got £470 in her bank. After she's paid electric, can she afford a washing machine? So to do this, you want to lay it out very similar to how they've laid it out. So you could literally copy their exact display here if you wanted to. Okay, so you could put period, previous meter readings, present meter readings, and that would be a perfect way. They've literally given you your design if you want to put it that way. I can't bother to do that, so I'm just going to lay it out a different way. So I'm going to work out her electricity she's used. So units used. So her previous meter, well, her current previous meter is 14,400, but her previous meter reading was 13,900, sorry. So that means she's used, take those 2 away, and you get 500. She's used 500 units of electricity. That is going to cost the units 21p, and she's used 500. So if I do 21p times 500, it wouldn't take very long to do that, and you get £105. Her standing charge has increased by 20 pence, so it was £7.60 plus our 20 pence to give it, I haven't put my pound signs anyway here, to give us £7.80. So that's for 3 months. So if I just times that by 3, and I get £23.40. So therefore her total charges, I'm using similar titles as the last one. So she had £105 plus her £23.40 to get £134. Nope, that's after I've added VAT, sorry. To get £128.40. Sorry, excuse me. Then we have to add VAT at 5%. So 5% of £128.40 is £6.42. So her amount to pay, Amount to pay. That says day, not pay. Oh dear. Amount to pay is £128.40. Add our £6.42 to get £134.82. So that's how much her electric costs. So amount in bank after, that says back, not bank, sorry guys. Amount in bank after electric that she's paid. So she had 470, she's paid £134.82. Again, it won't take you long to calculate this. I know I'm not showing my calculations on how like you can draw your boxes, like to times and stuff. I've already worked it out on my sheet, so I'm not writing that out again. So we got £335.18. So that's how much she has left. She can afford the washing machine then. So I put in just a statement at the end, like a conclusion. So she can afford a new washing machine as she has £335.18 left, and machine costs £330. So she'll have like £5.18 left. If you want to put that, that's fine. Okay, so there's a lot going on for that question. Question 5. Lena has 3 apple trees in her garden. She has a gala apple tree, 1 orange pippin tree, is that how you say it? And 1 pink lady tree. She picks 50 apples from each of her 3 trees and records the width of each apple as shown. Why would you do this? Lena constructs box and whisker diagrams for the widths of the apples collected from each of the 3 trees, because she has nothing better to do. Maybe she's into doing that, I don't know. So we've got gala, orange and pink lady. You should know a couple of things from this. I'm just going to label it on the gala. That's our middle, our median. That's our highest, so the biggest apple. That is our lowest, so the littlest apple. That's our lower quartile, that's our upper quartile. So you can calculate interquartile range by doing upper take away lower. Those are things you should 100% know. You were fine with box and whiskers. You told me you don't want to do any more of those because you know them. So complete each of the following statements. Apples from the something apple tree have the least median width. So you're looking at all the medians. Which one's the lowest one? Well, clearly, they're all in line, which is very helpful. So that's 61, that's 55, 67, and that one's 63, so it's 57. What was that? Orange. I'm not covering the rest of it. The median was 57. The range of the widths of the apples recorded on the gala tree is, so you want the biggest one, so 60, 1, 2, 3, take away 40, 1, 2. So 60, not 60, that's an 80. Sorry, 83, take away 42, which is 41. So the range is 41, biggest, take away smallest. The something apple tree has the greatest interquartile range of widths. Interquartile range is apples tree is that. So work it out. So do this one is going to be 80, take away the 50, so that's 30. This one's going to be 75, take away 46, which is 29. This one is 79, take away 46, which is 33. Do we want the biggest or smallest? Has the greatest interquartile range. So that's pink lady. Pink ladies. All the pink ladies. It was 33. Sorry, I keep going back and forth. So the pink lady one has the greatest interquartile range. The interquartile range is 33. Which tree has the highest proportion of large apples? You must give reasons for your answer. So you could have quite a few answers for this one. I think the marks team had 2. So I think they had, you could either say gala, but you have to say the reasons. So you could say gala because they have the biggest upper quartile, because that's 80. You could say pink lady because they have the maximum, the biggest one. You could also say gala because the median is 30, but this 50% here is bigger than 61. So you could say, as long as you back up by some sort of like evidence, like interquartile range, or your median, or your highest one, you can say anything. So I'm going to say gala because it's got the highest upper quartile. It's only 1 mark, you only need 1 explanation. Daniel has made a pizza. Ooh, lovely. After he has taken his share, he calculates that he has 0.83 of the pizza left. So that's recurring. Daniel shares what he has left equally between 3 of his friends. Calculate the fraction of the whole pizza each of his friends will have. Give your answer as a fraction in its lowest form. You can do this 2 ways. You can either, because you've got this much pizza left and you want to split it between 3, you can either divide that by 3 now. You can put that into a fraction first and then divide it by 3. You can do whatever you want. I'm going to divide first because you might not remember how to divide fractions. So I'm going to go, how many times is 3? Go into 0.83333, etc. We're going to get a recurring number. How many times is 3? Go into 0, 0, dot goes above. How many times is 3? Go into 8 twice with 2 left over. How many times is 3? Go into 21, 7 with 2 left over. 23, 7 with 2 left over, 7, etc. So the amount of pizza he has left is 0.2777, or that's each of his friends will get 0.277777 of the pizza. We want that as a fraction. So if x, this is recurring decimals now, if x was that, 10x, I want to times it by 10 to get 2.777, etc. 100x, I want to times it by 10 again, would give me 27.7777, etc. So you keep timesing it until you have your numbers after the decimal the same. Do you see how these are now the same? So I can subtract them. So I'm going to do 100x, take away 10x, is going to be 27.7 recurring, take away 2.7 recurring, which is basically 27, take away 2. So that's going to be 90x is 25. Therefore, to get x, it's 25 divided by 90. And I want that in its simplest form. What's the biggest number that goes into them? I think it's 5. So divide both by 5. And I get 5 over 18. So that's the fraction that each person has. I'm going to leave it there for part 1. Join me again for part 2.